Okay, these are the ideal gas law notes. Okay, when you combine Avogadro's law, Boyle's law, Charles' law, and Gay-Lussac's law, you get an equation that describes the relationship between temperature, pressure, volume, and the number of moles. This formula or equation works best for gases that obey the assumptions of the kinetic molecular theory. In other words, an ideal gas. Okay, most gases are not ideal, but it also can help you estimate certain properties. Pervnert, PV equals nRT. That's the ideal gas law equation. You guys need to know this. Now, P stands for pressure, and that can be any one of all the pressure units. Okay, volume does have to be in liters, though. Okay, volume has to be in liters. N is the number of moles, not grams. So, like in Avogadro's law, it could be the number of moles or grams. It is the number of moles only. Okay, no grams. You have to convert to grams. R is the gas constant, and we'll get to that shortly. And T is the temperature in Kelvin. Now, every once in a while, you're going to be given, I don't know, volume in milliliters. So let's go ahead and add a slide in. Okay, in order to convert, let's do some basic conversions that you're going to need for this gas law. First off, milliliters divided by 1,000 equals liters. So if you're given something in milliliters, you will want to divide that number by 1,000 to get the liters. Also, if you're given grams, so mass divided by molar mass gives you the moles, which is your N value, okay? Because sometimes you'll be given the mass, so you need to divide by the molar mass to get the moles. Now, sometimes I'm asking for the mass, so moles times molar mass, by the way, moles is N, times the molar mass gives you your mass, oops, which is in grams, okay? So you're going to need to know these conversions. So you might want to put them somewhere on your sheet for the quiz or for the test when we get to it. Okay, now we need to rearrange the equation. Unless you want to sit there and, if you want to sit there and try and figure out how to solve for P, how to solve for V, I don't care, that's fine, you can do that. But if you don't want to, if you want to have the equations written, I would write these on your sheet also. So if we're solving for P is going to be nRT with the V underneath it. So basically you move the V from the left-hand side to the right. And when you do that, you have to divide. Okay, same with the V when you're solving for V. It's nRT with the P underneath. Okay, now the N, if you're solving for N, you're moving the R and the T over to the other side. So you have to put them under the PV. And same with the temperature. If you're solving for T, you've got to put the NR underneath. Now notice I don't give you an equation for R. R is a constant, okay? I'm going to give you the values. You don't ever calculate the values, okay? They've been calculated a long time ago. So there's certain values for R depending on your pressure. Okay, so here are your R values. You have 0.0821. Now notice these units. These units tell you, like this is the one you're going to use if your pressure value is ATM. You use 0.0821. If your pressure unit in your problem is kPa, you're going to use 8.341. If it's millimeters of mercury or torrs, you're going to use 62.4. Okay, when you read the problem, you either are going to be calculating pressure and it will tell you what unit, or you'll be given a pressure. And whatever unit that pressure is in, that tells you what R value to use. Okay, let's do our first example. And just like all the others, you need to label P equals V equals N equals R equals T equals. You also have to define your variables, all 5 of them. So what is the pressure in atmospheres of a 1.45 moles? Now remember, N is the number of moles, so we're going to put that here. Sample of gas. If the volume is 20.0 liters And the temperature is 25 degrees Celsius. Well, remember, temperature has to be in Kelvin, so 298 Kelvin. Now, R value. We want atmospheres. So if you look back at that list, okay, of R values, you find the one that has atmospheres in it, and that's 0.0821. Now, I am not going to make you write out the liter.atm mole.Kelvin each time, okay? As long as you pick the right number, I know that you matched it up, okay? So if you don't want to write that unit, you don't have to. If you want to write it just because it helps you keep track, that's fine. Okay, so we're looking for P. So we're going to use the equation that's P. So P equals nRT with the V underneath. Okay, so we're going to have the number of moles, which is 1.45, our R value, and T, which is 298, all over our volume. When we do this on the calculator, we get 1.77 ATM. Okay, pretty simple, right? Well, let's try another one. Okay, so we're going to start out doing the same thing, going P equals V equals N equals R equals T equals. Okay, so what is the temperature in degrees Celsius, so I'm going to put that there, of a 1.10 gram sample? Oops, I've got grams instead of moles. Now it's a gram sample of oxygen gas. O2, okay, O2 is 32 grams per mole. That's our molar mass of oxygen. Now remember, on the previous couple slides ago, if you're given mass, you need moles here. So if you're given mass, you divide by the molar mass, okay, and that gives you the number of moles. So in this case, it is 0.0344 moles of O2 gas. Okay. Now, where were we? Sample of O2 gas in a 4.21 liters, remember liters are volume, container, at a pressure of 22.69 kPa. Okay, so I've got kPa. So I'm going to go back and look at my R values, and I find the one that has kPa in the units, and it's 8.341. Okay, so we're finding T, and T we know is PV over NR. So T equals 22.69 times the volume, which is 4.21, all over 0.0344 times 8.341. And what I get is 333. Now this is Kelvin, but it's asking for it in Celsius. So I've got to subtract 273. Okay, and then I get my... Now, you don't have to subtract, you don't have to report your temperature in Celsius unless the problem asks. If it just says what is the temperature of, and it doesn't tell you to put it in Celsius, you do not have to. You can, but you do not have to. You can leave it in Kelvin, which is actually much easier. Okay, let's try our third example. It's P equals V equals N equals R equals T equals. Okay, how much helium gas? Now remember, every time I ask you how much, I'm looking for grams. So I'm going to put this, only I'm going to put grams there. So that way I know I'm going to calculate moles, and then in the end I'm going to need to multiply by molar mass. So how much helium gas in a 32.6 liter container at a pressure of 798 millimeters of mercury at a temperature of 20 degrees Celsius, which is 293 K. Now, we go back to our R values. I've got millimeters of mercury, so I'm going to do 62.4. Okay, so N equals PV over RT. So P, 798 over 32.6. R is 62.4 times 293. When we do this, we get 1.42 moles. Now the gas is helium. Okay, so we're going to take 1.42 times molar mass of helium. He is 4.00 grams per mole. When you do this, you get 5.68 grams of helium. And that's it. So hopefully you guys can figure this out. I know you have to write out a lot, but oh well, get used to it. So we will do a little bit of a warm-up, and then we'll do a little worksheet along with all of our problems, which is 9:45 to 9:54. So I guess I'll see you guys tomorrow. Bye.